In question 1, we are told that the binomial expansion of 3 plus kx to the negative 2 with k being a non-zero constant is written in the form a plus bx plus cx squared plus dx cubed, and we need to find the value of a. Well, I will start by considering 3 plus kx to the negative 2. I will factor out the 3 inheriting the power of negative 2, and within the bracket we divide by 3, and everything is raised to the negative 2. So we're looking at 1 over 9, and I will be applying the binomial expansion on 1 plus kx over 3 to the negative 2. So it's 1 plus the power of negative 2 times the term of kx over 3. Then we've got the power of negative 2. We deduct 1 from the power over 2 factorial times kx over 3 all squared. And then it's negative 2 times negative 3 times negative 4 over 3 factorial times the kx over 3 to the power of 3 plus dot dot dot. I will proceed by simplifying. So we've got 1 over 9 times 1 minus 2kx over 3 plus k squared x squared over 3 minus 4k cubed x cubed over 27 plus dot dot dot. And if I further expand, we get an answer of 1 over 9 minus 2kx over 27 plus k squared x squared over 27 minus 4k cubed x cubed over 243 plus dot dot dot. Well, a is the constant term. We can see that a is 1 over 9, and therefore we conclude that a is equal to 1 over 9. Now, given that c is equal to 3b, we need to show that k squared plus 6k is equal to 0. Well, b is the coefficient of x, and we can see from the expansion we obtained that this is minus 2k over 27. So let me write b is equal to minus 2k over 27. c is the coefficient of x squared, so c is equal to k squared over 27. And we are told that c is equal to 3b, so k squared over 27 is equal to 3 times the negative 2k over 27. Now, obviously, the 27s will cancel out, and therefore we get that k squared is equal to minus 6k. I will be collecting everything on the left-hand side, so k squared plus 6k is 0 as required. In C, we are asked to find the value of k and the value of t. So for the value of k, I will be simply solving k squared plus 6k is equal to 0, which leads to k times k plus 6 is equal to 0. So either k is 0 or k plus 6 is equal to 0, which means that k is negative 6. Well, we have been told that k is a non-zero constant, so since k is not equal to 0, we conclude that k is negative 6. For the value of d, d is the coefficient of k cubed, which was minus 4k cubed over 243. I'll be substituting k to be negative 6, so minus 4 times negative 6 cubed, and all of it divided by the 243, which gives an answer of 32 over 9. In 2a, we are asked to express 1 over 1 plus 3x over 1 minus x in partial fractions, so we're dealing with 1 over 1 plus 3x times 1 minus x. So we are proposing a decomposition of the form a over 1 plus 3x, where a is a constant, plus another constant b over 1 minus x. Well, the LCM is 1 plus 3x times 1 minus x. So if I multiply throughout by the LCM, we arrive at 1 is equal to a times 1 minus x plus b times 1 plus 3x. Now, this is an identity, which means that it holds true for all values of x. So it would be great if we could set 1 minus x to be 0, because this will eliminate a altogether and will allow us to recover the value of b. So I will be setting x to be 1. So setting x is 1 leads to 1 being equal to b times 1 plus 3 times 1. So we're looking at 1 is equal to 4b, and therefore b is equal to a quarter. Now, another nice value for x will be the value that will make 1 plus 3x to be 0. So this is going to be x being minus 1 over 3. So let's set x to be minus 1 over 3, leading to 1 is equal to a times 1 minus the negative a third. So we're looking at 1 is equal to 4a over 3, and therefore we conclude that a is equal to 3 over 4. Now to finish off, we need to write down the partial fraction decomposition with the values for a and b we just obtained. So we conclude that 1 over 1 plus 3x times 1 minus x is equal to 3/4 over 1 plus 3x plus 1/4 over 1 minus x. In part B, we're asked to hence find the solution of the differential equation given here in light of x being a half when y is pi over 2, and we need to give our answer in the form sine of y to the power of n is f of x, where n is an integer to be found. So we start off with 1 plus 3x times 1 minus x dy dx is equal to tan y. I'll be separating the variables, which means I will be collecting y's with dy on the left-hand side and x with dx on the right-hand side. So we're looking at 1 over tan y dy on the left-hand side being equal to 1 over 1 plus 3x times 1 minus x dx on the right-hand side, and I'll be integrating both sides. Well, obviously 1 over tan y is cot y, so on the left-hand side we're dealing with the integral of cot y dy, and on the right-hand side we've got the partial fraction decomposition, which is 3/4 over 1 plus 3x plus 1/4 over 1 minus x dx. So I can proceed with integrating. Now the integral of cot y is given in the formula booklet. It's going to be ln of the absolute value of sine of y. Then the integral of 1 over 1 plus 3x will give me ln of 1 plus 3x. So we're looking at 3/4 over 3 ln of 1 plus 3x. Now the over 3 is coming from the derivative of 1 plus 3x, so I divide by the derivative. And then for the integral of 1/4 over 1 minus x, we get plus 1/4. I'll divide by -1, which is the derivative of 1 minus x, times ln of the absolute value of 1 minus x plus the constant of integration c. So we're looking at ln of the absolute value of sine y being equal to 1/4 ln of 1 plus 3x, because I have cancelled out the 3 with the 3. And then we've got minus 1/4 ln of the absolute value of 1 minus x plus c. I will now be using the fact that when x is a half, y is pi over 2, which leads to ln of sine of pi over 2 is equal to 1/4, and we've got ln of 1 plus 3 times a half minus 1/4 ln of 1 minus a half plus c. Now sine of pi over 2 is 1 and ln of 1 is 0. So on the left hand side it's 0 being equal to 1/4 ln of 5 over 2 minus 1/4 ln over half plus the constant c. Now we know that when we are deducting logarithms, then we simply do the quotient. So I'll be doing 5 over 2 divided by a half. So we now have 0 being equal to 1/4, and I've got ln of 5 over 2 divided by a half plus c. So we're dealing with 0 being 1/4 ln of 5 plus c. So we conclude that minus 1/4 ln 5 is the value of c. So we now have ln of the absolute value of sine of y being equal to 1/4 ln of 1 plus 3x minus 1/4 ln of 1 minus x minus 1/4 ln of 5. The first thing to do is multiply everything by 4. So this leads to 4 ln of sine y being equal to ln of 1 plus 3x minus ln of 1 minus x minus ln 5. The 4 here can go up as a power, so the left-hand side becomes ln of sine y raised to the power of 4, while on the right-hand side we've got ln of 1 plus 3x. We've got two subtractions here, so the 1 minus x and the 5 will be divided by, so they will appear in the denominator, and so the right hand side will be written as a single logarithm. It's going to be ln of 1 plus 3x over 5 times 1 minus x. Now we've got one ln on either side of the equal sign, so we can get rid of the ln's, and we conclude that sine y raised to the power of 4 is equal to 1 plus 3x over 5 times 1 minus x. In question 3, a tablet is dissolving in water. We are modeling the tablet as a cylinder as shown in figure 1 here. We are told that at t seconds after the tablet is dropped into the water, the radius is x millimeters and the length of the tablet is 3x millimeters. The cross-sectional area is decreasing at a constant rate of 0.5 square millimeters per second, and we need to find dx dt when x is 7. Well, we can see that the cross-sectional area is simply the area of this circle with a radius of x. So I will start by saying that a is equal to pi x squared. This means that dA by dx is simply 2 pi x. We have additionally been told that the dA dt, the rate of change of the cross-sectional area with respect to time, is negative 0.5. The negative is coming out of the fact that the area is decreasing, and therefore I can use the chain rule to say that dx by dt is equal to dx over dA times dA over dt. Now dx by dA is simply the reciprocal of 2 pi x, so it's going to be 1 over 2 pi x times the minus a half, which is the dA dt. So we're looking at minus a half over 2 pi x, and we are asked to find the value of dx dt when x is 7. So dx dt when x is 7 is equal to minus 0.5 over 2 pi times 7. If you plug this on the calculator, you get an answer of negative 0.0114, and it's millimeters per second. In part B, we need to find, according to the model, the rate of decrease of the volume when x is 4. So we know that the volume is going to be the cross-sectional area, which was pi x squared times the length, which is 3x. So this is giving me 3 pi x cubed. This means that dv dx is simply going to be 9 pi x squared. This means that dv by dt, again with the chain rule, it's going to be dv dx times dx dt. So dv dx, it's 9 pi x squared. dx dt, we found this to be negative 0.5 over 2 pi x, where there are some simplifications I could proceed with the pi, and then we've got the x squared with the x. This is giving an answer of negative 9x over 4. So we will evaluate dv by dt when x is equal to 4. So if we substitute this into the expression we just obtained, it's minus 9 times 4 over 4, which is negative 9. This is the rate of change. Be careful, the question is asking for the rate of decrease. So what we need to say here is that the rate of decrease is going to be the absolute value of negative 9. So it's going to be 9, and it's going to be cubic millimeters per second. In question 4, we've got the curve with this equation here, where k is a constant, and we need to obtain an expression for dy dx. This is a question involving implicit differentiation, so we differentiate from left to right. We apply all rules of differentiation as usual. If we happen to be differentiating a term in y, we put a dy dx term as well. So the derivative of 16x cubed is going to be 48x squared. And then for the derivative of negative 9kx squared y, I'll be applying the product rule. The derivative of 9kx squared is going to be minus 18kx, and I keep the y, and then I keep the minus 9kx squared, and the derivative of y, it's going to be dy dx, and then for the derivative of 8y cubed, it's going to be 24y squared dy dx, and then the derivative of 875 is simply 0 because that's just a constant. So we're looking at 24y y squared dy dx minus 9kx squared dy dx is equal to 18kxy minus 48x squared. Well, we notice that we can divide throughout by 3, leading to 8y squared dy dx minus 3kx squared dy dx being equal to 6kxy minus 16x squared. I will factor out the dy dx from the left hand side, so in the bracket I've got 8y squared minus 3kx squared, and this is equal to 6kxy minus 16x squared, and therefore we've got that dy dx is equal to 6kxy minus 16x squared, and all of it divided by 8y squared minus 3kx squared as required. Now, given that the curve has a turning point at x is 5/2, we need to find the value of k. Well, we know that the turning point means that dy dx is 0, and we have obtained an expression from part A. We are setting that to be 0. So we want the numerator here to be 0 when x is 5/2. This leads to 6k times 5/2 times y minus 16 times 5/2 squared is equal to 0. So we're dealing with 15ky minus 100 is equal to 0, which means that 15ky is equal to 100, and therefore y turns out to be 100/15k, which simplifies to 20/3k. Additionally, we've got the equation of the curve, 16x cubed minus 9kx squared y plus 8y cubed is 875. So I'll be substituting x with the value of 5/2, so 16 times 5/2 cubed minus 9k times 5/2 squared. In the place of y, I'm putting 20/3k, so I've got 20/3k plus 8 times 20/3k cubed is equal to 875. Let's simplify things. We've got 250 minus the 375 plus 64,000/27k cubed being equal to 875. This leads to 64,000/27k cubed being equal to 1,000. Obviously, the 3 zeros will cancel out. I will cross multiply to get 64 is equal to 27k cubed. I will divide both sides by 27 to get 64/27 is k cubed. And if we take the third root of 64/27, we obtain an answer for k, which is equal to 4/3. In question 5, part A, we need to use the substitution x is 2 sine u to show that the given integral from 0 to 1 can be written into this integral in terms of u from 0 up to p, where p is a constant to be found. Well, we know that in integration by substitution, we are doing a translation from x into u, so we need to translate the whole expression to be integrated, the dx, as well as the two limits. So we start with x being equal to 2 sine u as given by the question, which means that dx is equal to 2 cos u du. I will also translate the limits, so when x is 0, we get that 2 sine u is equal to 0, which means that sine u is 0, and therefore u is equal to 0. While when x is 1, 2 sine u is equal to 1. We get that sine u is equal to a half. If I do shift sine over half, I get that u is pi/6. I will next consider the 4 minus x squared raised to the power of 3/2, and I would like to express that in terms of u. So 4 minus x squared to the power of 3/2 is equal to 4 minus 2 sine u squared raised to the power of 3/2. So we're looking at 4 minus 4 sine squared u raised to the power of 3/2. I will take out a factor of 4. So we're looking at 4 brackets 1 minus sine squared u raised to the power of 3 over 2. Now we know that 1 minus sine squared is cos squared. So this is 4 cos squared u raised to the power of 3 over 2. Well, 4 to the power of 3 over 2 is simply 8. And cos squared raised to the power of 3 over 2 is cos cubed u. So this means we can proceed with the integral from 0 up to 1 of 3x plus 2 over the 4 minus x squared raised to the power of 3 over 2 dx. And I'll be expressing everything in terms of u. So the new limits are 0 and pi over 6 respectively. Now 3x will be 3 times 2 sine u plus 2. The denominator, we said it's 8 cos cubed u, and in the place of dx I'm putting 2 cos u du. Now the first thing we notice that the 8 with the 2 leave me a 4 in the denominator, and then the cos u with the cos cubed u will leave me a cos squared u term in the denominator. So we're looking at the integral from 0 up to pi over 6 of 6 sine u plus 2 over 4 cos squared u du. So I will split this as the integral from 0 up to pi over 6 of 6 sine u over 4 cos squared u plus 2 over 4 cos squared u du. I will simplify the 6 with the 4, leaving me a 3 and the 2 in the denominator, and the 2 with the 4, leaving me with 1 and 2. So all in all, we're looking at the integral from 0 up to pi over 6 of 3 sine u over 2 cos u times 1 over cos u. So what I did is that I have split the cos squared u term as cos u times cos u. And then the second term here, the 1 over 2 cos squared u, is obviously 1 over 2 sec squared u du. So all in all, we're looking at the integral from 0 up to pi over 6 of 3 over 2, and we've got tan u sec u plus a half sec squared u du as required. In part B, we are asked to hence find the exact value of the integral. So we have already established that we are looking at the integral of 3 over 2 tan u sec u plus a half sec squared u. Now both of these are standard integrals. The integral of sec tan is simply sec. So this is 3 over 2 sec u. And the integral of sec squared is tan u. So plus a half tan u. The limits are 0 and pi over 6. So I will start by substituting the upper limit of pi over 6. So this is 3 over 2 sec of pi over 6 plus a half tan of pi over 6. And I will be deducting the lower limit substituted, which is going to be 3 over 2 sec of 0 plus a half tan of 0. So let's see what we get here. We're looking at root 3 plus root 3 over 6 minus 3 over 2. The 3 over 2 is the 3 over 2 sec of 0. The half tan 0 is simply 0. So if I simplify all of these, we get 7 root 3 over 6 minus 3 over 2. In question 6, we're given the position vectors of points A, B, and C, with the point C being given in terms of P, where P is a constant. We are told that the line L passes through the points A and B, and we need to find the vector equation for the line L. I will start by finding the vector AB because that's the direction of the line. So for AB, I'll be doing the vector B, so 5, 3, negative 2, minus the vector A, which is 1, negative 4, 3. So we're looking at 4, 7, negative 5. This is the direction vector of the line L. we will take one of the 2 points to act as the position vectors. I could take either point A or point B because we know that the line passes through both of these points. I'm going to take point A. So we're looking at 1, negative 4, 3, plus lambda times the direction vector, so plus lambda times 4, 7, negative 5. We then have that AC is perpendicular to L and we need to find the value of P. Well, I will start by finding the vector AC, so I'll be doing C minus A. So we're looking at 3P negative 1 minus the 1, negative 4, 3. This gives an answer of 2P plus 4 minus 4. We know that if two vectors are perpendicular, then their dot product it's going to be 0, so I'll be dotting AC with the direction of L, which is given by the direction vector of the line. So we're looking at AC dot the 4, 7, negative 5, which gives me 2P plus 4, negative 4, dotted with the 4, 7, negative 5. Well, we know that if we are applying the dot product, then we are multiplying the I with the I, the J with the J, the K with the K, and adding everything up. So 2 times 4 is 8. Then we've got 7 times P plus 4. And then we've got the negative 4 times the negative 5, which is plus 20. So I will proceed in simplifying things. We are looking at 8 plus 7P plus 28 plus 20, which further simplifies to 7P plus 56. We know that this should be equal to 0 if the two directions are perpendicular. So we've got 7P being equal to negative 56, which means that P is equal to negative 8. In part C, we are asked to find the area of the triangle ABC, giving our answer as asserted in its simplest form. Well, let's start by drawing a line. This is the line L. We have the point C with coordinates 3, negative 8, negative 1. We have the point A on the line with points 1, negative 4, 3. We know that this here is a right angle because AC is perpendicular to L. Additionally, we've got the point B with coordinates 5, 3, negative 2 on the line. So I can form the triangle here. It's a right angle triangle and I need to find its area. So I will start by finding the base, which is AB. So I'll be applying Pythagoras in 3D. So I'm doing 5 minus 1 squared plus 3 minus negative 4 squared plus negative 2 minus 3 squared and all square rooted. This gives an answer of 3 root 10. And then for the height is AC. So the AC will be given by 3 minus 1 squared plus negative 8 minus the negative 4 squared plus the negative 1 minus 3 squared, and again all under a square root. This gives an answer of 6, and therefore the area of the triangle is simply base of 3 root 10 times height of 6 over 2. This simplifies to 9 root 10 units squared for the area of the triangle ABC. In question 7, we've got the curve C defined parametrically here. T varies between 0 and 5 inclusive, and we need to show that dy dx is 3 when t is pi. I will start by obtaining expressions for the x dt and dy dt. Well, the derivative of x with respect to t will give me cos t, and then for the 3 cos square t, we've got minus 3, and then we get the power down. We deduct 1 from the power times the derivative of the bracket. Well, this simplifies to cos t plus 6 sine t cos t. And then for dy dt, we will proceed by differentiating 3 sine t to give me 3 cos t, and the derivative of 2 cos t is minus 2 sine t. Well, we know that dy dx is given by dy dt over dx dt. So in our case, we are looking at 3 cos t minus 2 sine t over the cos t plus 6 sine t cos t. I will be substituting t is pi, so we're looking dy dx at t is equal to pi, which gives me 3 cos of pi minus 2 sine of pi over cos of pi plus 6 sine pi cos pi. You should be showing the substitution here because you are dealing with a show that question, so you need to show exactly the method. Now if you plug this on the calculator, you get exactly the answer of 3 as required. We then have that the point P lies on C where t is pi, and we need to find the equation of the tangent, giving our answer in the form y equals mx plus c. So let's start with the value of the parameter t is equal to pi. This means that x is equal to sine of pi minus 3 cos squared pi. So we're trying to find the coordinates of the point. This gives an answer of negative 3. And for y, we're looking at 3 sine pi plus 2 cos pi, which gives an answer of negative 2. Well, we know that the equation of the straight line is given by y minus y1 is mx minus x1. So we're looking at y minus the negative 2 is equal to the gradient of 3 we obtained in the previous part times x minus the negative 3. So we're looking at y plus 2 is equal to 3 brackets x plus 3. I will expand the right hand side to get y plus 2 is 3x plus 9, leading to y is equal to 3x plus 7. We're then told that the tangent to the curve at P cuts the curve at the point Q, and we need to show that the value of t at the point Q satisfies this quadratic in cos t. So where do we stand at the moment? We've got these parametric equations describing the curve and this equation for the tangent. So I'll be combining everything together by substituting x and y into the equation of the straight line. So in the place of y, I'll be substituting 3 sine t plus 2 cos t, which is equal to 3 times x, so 3 times sine t minus 3 cos squared t, close brackets, plus 7. Well, let's expand to get 3 sine t plus 2 cos t is equal to 3 sine t minus 9 cos squared t plus 7. The first thing we notice is that the 3 sine t terms will cancel out, and then I'll be collecting everything on the left hand side, leading to 9 cos squared t plus 2 cos t minus 7 is equal to 0 as required. And indeed, we are asked to hence find the exact value of the y coordinate of q. Well, I will take the quadratic in cos t. I will factorize this into 9 cos of t minus 7, the first bracket, times cos t plus 1 being equal to 0. So we're looking at 9 cos t minus 7 is equal to 0, or alternatively cos of t plus 1 is equal to 0. So we've got cos of t is equal to 7 over 9, or cos of t is equal to negative 1. Well, if cos t is negative 1, this obviously means that t is equal to pi, which corresponds to the point P. That's not the point we're interested in. We're interested in the point where cos t is equal to 7 over 9. And instead of proceeding in finding the value of t, I will simply draw a right angle triangle. We know that cos t is 7 over 9, so 7 is the adjacent, 9 is the hypotenuse. I'll be using Pythagoras to get the opposite, so we've got 9 squared minus 7 squared square root, which gives an answer of 4 root 2, which of course means that sine of t is equal to 4 root 2 over 9. Remember, we're trying to find the y coordinate of the point Q, and we know that y is equal to 3 sine t plus 2 cos t. So we know that sine t is 4 root 2 over 9, so 3 times 4 root 2 over 9 plus 2 cos t, so plus 2 times 7 over 9. Well, all of this simplifies to 12 root 2 plus 14, and all of it over 9. In question 8, we're given the curve with equation y is 10x e to the minus a half x, with x varying between 0 and 10. Now the region R, shown shaded here, is rotated through a full revolution about the x-axis, forming a solid of revolution. and we need to show that the volume capital V of this solid is given by this expression. Well, we know it's a standard result that the volume of revolution when we are rotating about the x-axis is given by pi the integral of y squared dx. Now the limits will be 0 and 10. I'll be replacing y squared with 10x e to the minus a half x squared. So it's pi, the integral from 0 up to 10, and we've got 10x e to the minus a half x raised to the power of 2 dx. Now obviously the 10 squared will give me 100 that can come out of the integral. So we're looking at 100 pi, the integral from 0 up to 10, x squared e to the minus x dx. This is because x squared is simply the x squared term here, and e to the minus a half x raised to the power of 2. I multiply the indices together, leaving me with e to the minus x. In part B, we're asked to find the integral of x squared e to the minus x dx, and I'll be using integration by parts. We know that the rule here says that the integral of u dash v is uv minus the integral of uv dash. So when dealing with the integral of x squared e to the minus x dx, I'll be setting u to be x squared and v dash to be e to the minus x. So u dash will be the derivative of x squared, which is 2x, and v will be the integral of e to the minus x, which will be negative e to the minus x. And therefore the integral of x squared e to the minus x dx will be uv, so minus x squared e to the minus x minus the integral of u dash v. Now we can see that this minus here will make the minus outside of the integral positive, so we've got plus the integral of 2x e to the minus x dx, and I need to reapply integration by parts on this integral. I will now be setting u to be 2x and v dash to be e to the minus x, leading to u dash being 2 and v being minus e to the minus x, and therefore the integral of 2x e to the minus x dx will be uv, so minus 2x e to the minus x, minus the integral of u dash v. Again, the negative sign here will make this negative positive, so it's going to be plus the integral of 2e to the minus x dx, and I can proceed in finishing off the integral here. We are looking at minus 2x e to the minus x minus 2e to the minus x plus c, and therefore to conclude, the integral of x squared e to the minus x dx will be equal to minus x squared e to the minus x plus what we have obtained here with the second integration by parts. So we're looking at minus 2x e to the minus x minus 2e to the minus x plus c. We're then told that figure 3 represents an exercise weight formed by joining two of these solids together. Now this exercise weight has a mass of 5 kilograms and a length of 20 centimeters. We know that density is equal to mass over volume, and we need to use our answers to find the density of this exercise weight, giving our answer in grams per cubic centimeters to 3 significant figures. So this is the situation here. We're trying to find the volume of this exercise weight. I will superimpose a set of x and y axes. So we already have a formula to find the volume of this part here. So I will just double my answer to get the full volume of this exercise weight. So we're looking at the total volume being 2 times pi times the integral from 0 up to 10 of y squared dx. Well, we have seen that this is equal to 200 pi times the integral from 0 up to 10 of x squared e to the minus x dx. And remember, from part B we have found the integral of x squared e to the minus x. So we're looking at 200 pi times the minus x squared e to the minus x plus 2x e to the minus x minus 2e to the minus x, with the limits being 0 and 10. So let's proceed in substituting the upper and then the lower limit. So we're looking at 200 pi, and then we've got the upper limit substituted, so it's minus 10 squared e to the minus 10 minus 2 times 10 e to the minus 10 minus 2 e to the minus 10, and then I need to substitute the lower limit. Obviously this term and this term here would be 0, and I'm left with minus 2e to the minus 0, which is simply a negative 2. So minus a negative 2 here. Let's proceed in simplifying. We're looking at 200 pi times minus 100 e to the minus 10 minus 20 e to the minus 10 minus 2 e to the minus 10 plus 2, and all of this gives me a numerical answer of 1253.156936 cubic centimeters. And therefore, using the fact that the density is equal to mass over volume, where we have been told that the mass is 5 kilograms, because I need to end up with grams per cubic centimeters, 5 kilograms is equal to 5,000 grams. The volume has been found to be 1253.15 ... cubic centimeters, and this gives an answer of 3.99 grams per cubic centimeter. In question 9, we need to use proof by contradiction to show that when n is an integer, then n squared minus 2 is never divisible by 4. As always, we start by assuming the exact opposite of what we need to prove, what is known as the negation of this statement here. So we say suppose not, i.e. n squared minus 2, where n is an integer, is indeed divisible by 4 for some value of n, not for all values of n, but for at least one value of n. And therefore I can proceed. Since this is divisible by 4, we can conclude that n squared minus 2 must be 4 times an integer k. So k belongs to the set of integers. This means that n squared is equal to 4k plus 2. And on the right hand side, we can factor out the 2, leading to 2 times 2k plus 1. Now, obviously, the right hand side is even because it is 2 times an odd number, and therefore I conclude that n squared is also even, and this means that n is also even, and if n is even, we can say that n is equal to 2m for some m in the integers. So let's substitute n being 2m into this equation here. We are looking at 2m all squared being equal to 2 times 2k plus 1. So we've got 4m squared is equal to 2 times 2k plus 1. I can simplify the 4 with the 2, leaving me with the 2 on the left-hand side. So we get that 2m squared is equal to 2k plus 1, which is surely a contradiction because we can see that the left-hand side is surely even, but the right-hand side is odd. So we cannot have an even number being equal to an odd number. So I need to write contradiction and an overall conclusion. Hence, n squared minus 2, where n is an integer, is never divisible by 4.